equations, we're going to talk about growth and decay today. Okay? Exponential growth. Whoops, I have growth and decay. I'll change it. Exponential growth. The more you have, the more you get. Exponential decay, the less you have, the less you get. That should be something that I don't need to talk about, right? Okay? Quantities that grow or decay by a factor or percentage at regular intervals are exponential. Okay? We can describe this as the rate of change of the quantity is directly proportional to the quantity itself. Back in algebra, you guys talked about inverse proportion, direct proportion, joint proportion. You kind of remember that? No, thanks for being honest. Okay, when we talk about something being directly proportional, let's say y is directly proportional to x, then you have y equals a constant times x. Okay? So if we're saying that the rate of change is directly proportional to the quantity itself, then we're saying as our quantity changes over time, because that's when we're talking about growth and decay, we're talking about something growing or decaying over time. So the change in y over time, here's our growth constant is directly proportional to the quantity itself. Okay? Now, we just went through differential equations, right? So we can actually solve this for what y equals, correct? Let's do it. Okay, so we need to separate our variables, correct? What are our two variables? Y and t. So where I have a dy, I'm going to divide my y over. And my k is good. It really can be anywhere, but I'm going to keep it over here and multiply my dt over there. Okay, so now let's integrate. What do we have on the left side? And on the right side? K what? KT plus T. Alright, now we want to get y equals, right? Right. Okay, so x exponentiate both sides. These cancel, and we have the absolute value of y equals, I'm going to write this as e to the kt times e to the c, right? Okay? However, e to the c is a constant. So the absolute value of y is a constant times e to the kt. To get rid of the absolute value, we put a plus or minus here. Well, whatever the c constant is, it'll tell us whether it's going to be positive or negative. So we're just going to say y equals c e to the kt. Okay? So, if you see that your rate of change is directly proportional to the quantity, instead of writing this and going through this process every time, you know that it's going to be y equals c e to the kt. If you can remember this, you can do the problem. Okay? Most of these problems are going to be algebra based instead of calculus based because we just did the work for the calculus right here. All right? So, here we go. Example number 1. The rate of change of y is proportional to y. Okay? Well, that tells us that we know y equals c e to the k t. They give us some information. When t is 0, y is 2. When t is 2, y is 4. What is the value when t is 3? Okay? Why did they give us that information?
Find k.
And we need both the constant that's out in front and we need our constant that's either going to tell us whether it's growing or decaying. Let's think about it. Are we growing or decaying? So k better be positive. All right. Easiest one to plug in first is when time is 0. So when time is 0, y is 2. So 2 equals c e to the k times 0. Do you think that'll happen every time?
Probably.
Okay. If you have a time at 0, e to the 0 is always going to be 1. Now let's use when time is 2, y is 4. So y is 4. We know that c is 2. And our time is 2. Okay. So, how do we solve this? Divide by 2. Now what? Natural log. So we have the natural log of 2 equals 2k. Okay. Now, most of these problems are going to occur in the calculator section of the multiple choice portion. Okay? So you can either leave k as this. If you approximate it to a decimal, you're going to want a good 6 or 7 decimal places. Okay? All right, so we have y equals 2e. What is our k value? Anybody put it in your calculator? 0.34657. 0.3. Okay. So now we're going to evaluate this when t is 3. What is y? That is what I got. Anybody else confirm? Okay. Any questions? Okay. Now, this is a very basic example because everything was just laid flat out for you. Most of the time, we're going to be working with some sort of sciencey problem. Yay, science. Okay. Okay. So, rate that this decays, is proportional to the amount. Okay, I did not write that in this example, so I'm going to tell you that right now. Okay, we have 10 grams released, and I want to know how long it's going to decay to 1 gram if we know the half-life is 24,360 years. Okay, so I told you that the decay is proportional to the amount, and so we know we're working with this. In order to figure out when we are going to get to 1 gram, I need an equation. So I need to know C and K. Okay. When it says 10 grams are released, what's the time? 0. So our initial amount is 10. So we know that C is 10. Now we need to find K. First of all, is K going to be positive or negative? Negative. How am I going to find K? Okay. Half-life means what? Okay, after a certain period of time, we're at half the amount. What is half of our amount? 5. So we are at 5 when time is 24,360. All right, because the half-life is that many years, so that's how long it takes to get to half its amount. All right? So, I want you to notice something. When I divide over the 10, I have 1/2 equals this. Do you think that's a coincidence? No, it is not. Okay? Go ahead and solve for K for me, please. Hold on. What is K? Negative 2.4 times 10 to the negative 5th. So our equation, y equals 10 e to the negative 0.000002 8. It should be 4 zeros, right? 28454 t. All right. Now I want to know how long will it take to get to 1 gram. So where does 1 go? Okay, I'm not going to write it out again. Starting from a great K. Okay. So we have 1/10 equals e to that number times t. So what do we have to do? Natural log of 1/10 equals negative 0.000028454. like your years. In this case, let's round to the nearest year. So that would be how many?
8,910.
And 923?
Yeah, that's right.
Well,
Nine or 20 years and a half.
What do you mean by half-life?
What half life is 24,000 years.
Oh, no, I want, because it says years. Yeah.
do you want it rounded up in years or rounded up? Like, okay, do you want it rounded to
Round normally.
round normal?
Yes. Does that answer your question?
Yes.
Okay. Beautiful. Everyone okay with this problem? One more example. And look, it's a multiple choice.
Best time, get your point in, call your check.
What's a kudzu?
I don't know.
You should know that.
It's a plant of some kind.
Okay.
The rate at which an acreage is being consumed by a plot of kudzu is proportional to the number of acres already consumed at time t. There are 2 acres consumed when t is 1, 3 acres consumed when t is 5. How many acres will be consumed when t is 8? Okay. Well, the rate at which the acreage is being consumed is proportional to the number of acres already consumed at that time. So we get to use our fancy y equals c e to the k t. What is different about this problem than the past couple problems? We don't have t equals 0. So it's going to look a little bit different. Okay. However, we do have 2 acres are consumed when t equals 1. And we know that 3 acres are consumed. Oh, sorry, yes. I wrote the wrong variable. Thank you. And this is 3 when t is 5. What can you do? How are they equal? This is 2, this is 3. We have 2 variables in both, don't we? You could. Let me give you an easier way than doing like a substitution. What were to happen if I took the second one and divided it by the first one? 3 halves equals I divided the 2 equations to get rid of that c. They're proportionally equal. Would you rather solve for
No.
c with natural log? Okay. So k, well, natural log of 3 halves equals e to the 4k, correct? So k is, k is the natural log of 3 halves over 4. Now, I can plug k in right here to solve for c, correct? Okay, so what is an approximation for k? Okay. So let's plug that in right here. when t is 1, because then we just have a coefficient of 1 for k. And what does that make c? You have to take 2 divided by c. 1.8. Go a little further. One more. Okay. So we're worried about when time is 8. So what's our correct answer?
C.
You guessed it? Nice. Okay, so your homework. Page 366. 25. Nope, 21. 22. 25. Oh, thanks. 41. 42. 57. 58. Not that many problems. And you have a good chunk of time to work on it, and you will be working on it.